All right. Hi, everybody, and welcome to this first Fireside chat, Valohai Fireside chat. Today, and for the first time, I have our CEO Eero with us. Welcome.
Thank you. Thank you.
As you can see, we have a fireplace. We have some Norwegian woolen socks, and we have a baby shark. Baby shark. Yes. The idea with the Fireside chat is to talk about latest trends in machine learning. Uh, Eero, maybe you could start with some background of how Valohai was started and you got into ML through Valohai and so forth.
Yeah. So the reason Valohai was started was this goes quite deep actually.
Yeah.
I personally think that our society is sort of twisted. People should actually enjoy life more and work less.
Yeah. So that's why you started a company.
Yes. Yeah, it doesn't make sense on that level, but hear me out.
Yes. All right.
So when we started looking things where we could impact automation of work to enable new types of societies where people shouldn't have to work as much and they could enjoy life more. Obviously, deep learning was the biggest new type of technology that enables us to automate jobs. And we didn't want to like solve some individual problem inside that space, but more think of things that could cause ripple effects in the space where we could actually like make a much bigger impact globally in adaptation of deep learning. And when we started looking at that, most of our team comes from DevOps and engineering background, and we had been doing really rigorous, good DevOps stuff for the past 10 years. We realized that there's a huge mismatch in deep learning where people are doing most of the stuff manually that should be automated if we look from like software engineering perspective. So that's how we came up.
So you mentioned deep learning a lot. Is there sort of something specific you see in deep learning as opposed to machine learning as a more broader term?
Yeah, for sure. So if we look at machine learning as a sort of the big picture, there's what I like to call classical machine learning, where you have more simple models, stuff like regression algorithms and random forest, stuff like that. And then on deep learning side, we have usually deep neural networks. I think that there's a fundamental difference in how these kinds of like deep learning problems and classical machine learning problems will be tackled in the future. Yeah. Just because classical machine learning problems don't require as much compute, and that has led into the rise of AutoML. And classical machine learning, I think more and more in the future will be solved by AutoML platforms where you just like make your data nice and then plug that in, and then you will try the usual suspects for that type of a problem, and then it will automatically automate that for you. So there's not as much data science involved, whereas deep learning requires such an intense amount of computation that it won't be possible to do any kind of significant AutoML, at least large-scale AutoML. Obviously, we can do hyperparameter optimization and so on, but like really going through all the types of architectures of neural networks that we understand and know, it's not really feasible today. So it will be a much more manual kind of task. And I think if we look at parallels to, for instance, web development, like blogs can be done with WordPress, but if you want to build a more complicated platform, you will start with working with something like Django or Ruby on Rails and stuff like that.
Yeah, and even websites and web applications.
Exactly. Yeah.
So you touched a little bit upon some trends already, like deep learning happening more and more in the future, machine learning being more traditional. Any other trends that you've come across? I mean, you've lived in the US now for a couple of years and seen trends in San Francisco in the Valley and other companies, both big and small, working with machine learning. What are sort of the big trends that you see happening in the past few years?
Well, I think like just the sheer adaptation rate is going up really fast in companies for both machine learning and deep learning. Deep learning, of course, being still the outlier. It's much less used than classical machine learning methods. that I think, especially in the US, most companies already utilize machine learning for something. And then I think that there has been a really quick shift from like focusing on data to focusing on in production.
Yeah.
Still, a small minority of companies are focusing on like how to do this at scale in production. But if I think about like 2 years ago, the conversation was mostly like theoretical, like what kind of models could have been or might be interesting for these kinds of problems. And nowadays it's like, how do we deploy this at scale? Like, how do I train this on 100 GPUs? How do I run inference with a very small latency? And how do I run inference on edge and stuff like that?
Do you see any sort of differences in geographical adaptation between Europe and China and US, or any kind of geographical distributions?
Yeah. Well, it's hard for me to talk about Asia in general or China because I haven't really interacted with China.
Okay.
So, like people talk about China a lot, and the adaptation rate is really high there. But I can't speak from my own experience. What I can speak of is seeing like the Europe and US. US is definitely ahead. I think one of the big reasons is that there's the culture of adaptation of technology really fast, and I think this is why we see so many startups coming from the US versus Europe. In terms of capability, I don't think there's a big difference. I think that on average, like we have really great universities that have done research around AI in Europe, and I don't think that if you take an average like data scientists in the Bay Area and an average data scientist in Europe, I don't see a difference there. In terms of capability, I think the difference is in sort of like the US wants to go do the moonshots. They want to be the first in the market, and they really understand this. And also the money is there. You can get the funding, and whether it's like corporate funding, people are willing to invest in new ideas inside corporations, or then just sheer amount of VC money that's available.
So two interesting things here. Let's touch first upon startups that you mentioned. What do you see in like the machine learning space, like companies that you've interacted with, maybe customers, maybe something else that you've seen? What are the startups building? Like machine learning as a term is huge. So what are the startups actually trying to solve?
Well, that's a big question. First of all, I think like on average startups are usually fluff. It's sad to say, but like most startups that are AI startups are not really doing any machine learning. There maybe have some heuristic, and then they plan on gathering data and then training models. And the reason being that if you want to do any kind of significant machine learning, or especially deep learning, you have to have significant data sets that give you a competitive advantage. And if you're a new company, you don't have that data set. Like there's only open data available, and you can't do anything proprietary with that. You might, but like usually you don't get the big competitive advantage. Then again, if we look at larger companies, that's a different story. So that usually it's larger companies that are doing, and the smartest startups that I see are companies that are somehow coupling with larger enterprises and getting access to that proprietary data by some means. It might be like good partnership agreement that allows them access to the data and train the model and then keep the IP, or something like this, and then being able to leverage that. So I think like those are the most interesting companies that I've seen.
There was actually a question from one of the audiences or the signups here earlier. Yeah, that's a question I was going to ask. That could we turn down our fireplace a bit? Our fire is hazardous here.
Yeah.
So one of the questions was about current big players in the market. How are they reacting to machine learning as a trend, or do they build tools around it? Do they see it as killing maybe their business in some way, or how are they reacting?
Big players in the field. Do you mean like cloud providers or?
For instance, yes. Yeah, that could be one.
So obviously cloud providers are all like heavily investing in GPU compute, and Google coming up with TPUs, and well, Azure is playing around with the FPGAs for inference. So they're making big plays on the hardware side. But also coming to sort of on the software side and trying to figure out how to make this hardware more accessible for data scientists who usually aren't that good with software development. well, there's like tools like ours, Valohai. We partnered with Microsoft, for instance. Well, we partnered with all the cloud providers, but uh, so they are definitely on the lookout for different tools that would help companies utilize. But there's a lot of movement in the field. I think everybody is doing some sort of play on all the layers of the stack.
Sounds good. Sounds good. So maybe one thing that we touched startups and we touched larger players. Let's talk about venture capitalists for a while.
Mm-hmm.
So how have you seen that? How do they think? What do they think about machine learning in general, or deep learning, or AI in general?
Mm-hmm. So I think that a lot of the VCs have burnt their fingers for the first time already.
Yeah.
So like there's the huge AI boom, and then they realize that whoa, this is actually a bit more difficult than maybe we thought. And
Yeah.
every company that's an AI company probably isn't actually an AI company.
What? It's not enough that you have a .ai domain.
Yeah,
What?
I guess that wasn't enough at some point, but it's starting to get harder and harder. VCs have figured out ways to do more in-depth tech DD around AI.
How do they do that? Do you have any thoughts or experience?
They've just found the right people in the network to look into that stuff. They've found new people that they have bring on their like boards or advisory boards who are specialists who are able to assess the IP. VCs rarely have the knowledge themselves, but they usually rely on companies. And then also when they've worked with a few AI companies, like in their own portfolio, they've made a few investments, and then they have seen, okay, like this is the company that's actually doing something, and this is the company that's not actually doing something. So they just utilize their portfolio to do the DD.
Yeah.
We are now raising. It's not just one; it's actually several VCs that have put us in touch with their existing portfolio companies to do some sort of tech DD. And I think that's a great way to do it.
Sounds good. So a lot of companies, both big, small, and sort of funding is interested in AI still. Let's go back to the let's say the players, the smaller and the larger ones who are building the technologies themselves. I mean, we are a machine orchestration platform in a sense, at least. What kind of different categories of let's say AI tools for building, not like the end products that you're building, but sort of tooling around AI? What kind of products are there right now?
Yeah. Well, first of all, there's the data platforms and data lakes, any kind of stuff to organize your data.
What's cool that's happening over there at the moment?
Well, one thing is multi-cloud. I think a lot of, or just like, well, even like just sort of multi-endpoint, because it can be also private like some sort of private data center on and then cloud, and so just having the possibility to make that very fluid automatically.
So like replication of data and,
yeah,
and
making
bringing it all together behind one API. And
exactly, yeah, making it extremely transparent and like easy to do. It's a very complicated problem.
Yeah.
Companies that we've also partnered with, like MapR, for instance, are doing a great job there. Another thing being data versioning. This is a very complicated task again. All sorts of legislation and compliance will require you to be able to show that it was this data set that you used for this particular use case, and there's multiple reasons for that, but it's a complicated problem again. Like when we can go to like terabyte, petabyte scale and be able to version your data, you can't just take a copy of it every time.
Yeah, 100 terabytes of data every training execution. It adds up to quite large sums.
Yeah, it's not feasible. It's a really hard problem. Both for like structured data that goes in databases, but also then like unstructured data like images, audio, NLP, stuff like that.
Yeah.
So that's the data area. Then there's like, of course, like ETL tools on top of that, like doing data transformation. I see a lot of Spark out there for transforming data. If we're talking about structured, of course, not that good for images and stuff like that.
Okay, besides data itself, any other?
And then we use, when we go to compute. Compute is, I think, the one that's lacking the most. That's the area where we are today. the reason why I think it's lacking that it's the last one that people have to focus on. So it's sort of coming sort of a little bit behind. Actually, surprisingly,
Inference even.
after inference even, because you have to deploy, and usually when you get to the deployment point, you get someone on board who is actually knows what they're doing.
Yeah.
So like an engineer. So they usually take the good stuff that they've used, and inference is actually pretty similar. If we're talking about like online stuff, it's actually pretty similar to like for instance web services. It's usually a REST API, and the scalability is pretty easy and so on. Training is much more complicated in terms of like scalability. Well, usually they have different kind of problems. Let's say like that. I'm not gonna say that the inference is easy. No. That's for sure. It's not easy to deploy. It's very complicated. But there's great tools on the inference side. Stuff like Sheldon, for instance. I've seen some companies use. We've looked into it ourselves too. It's very interesting.
Yeah.
But also other stuff, like you can use some like pre-existing stuff, like just serving on top of like Kubernetes engine or stuff like that. I've seen companies do, and it's worked rather well for them.
How about, okay, let's talk about the training part a little bit more. We talked about the orchestration and that part of the training, but still there's lots of frameworks. They're probably building more abstraction layers, so it's easy to get started. There's probably tooling around that as well. Any thoughts on what's happening over there?
Well, frankly, it's moving really, really fast. That's the first thing that I see. Like, there's probably a new thing coming out every week that we look at to a certain level on our roadmap, and like sort of put in our like map that, okay, this is something that we have to look at. Will it die? Will it grow? And if it grows, what time? How does it affect our pipeline? Where do we put it in? Do we decide to support it? Do we decide to not support it?
Is it like from 0 to like amount of JavaScript libraries coming out every week? So are we there already?
I don't think it's quite like the amount of JavaScript libraries, but it's getting close at least. And they overlap too now with TensorFlow.js.
Oh yeah, that's true.
Yeah, no, it's not there yet, but I don't know if it's going to be like as bad. But there's definitely a lot of movement back and forth, so like things coming out, and I think the thing that I see the most is that it's very unorganized. There's not there's no good consensus about how to do this stuff. And I think that there's going to be a few good ways to do a few different kinds of things. First of all, like how to do classical machine learning versus deep learning. And then one of the things that I think requires a sort of a separation is the exploration phase and then the actual production phase. And they look a little bit different. And I think people are going to start thinking of in a more structured way how to think of these. Like the exploration is going to look a little bit like this, and then the actual productionization is going to look a little bit like this, and these are the tools that we're going to use there.
So do you see that there's same kind of trends as like in the 90s when I started programming with Pascal and Turbo Pascal, or even Basic before that, but still one coder did everything. Do you see the same kind of trend happening that right now in software engineering we have like front-end, back-end developer, DevOps guys, and DBAs and so forth? Are there specializations in machine learning happening as well?
Yeah, for sure. So first of all, we like people talk about data scientists. Like I think just last week somebody said that I've worked in the data science field for 10 years now, but I still don't know what the data scientist is. I think so too. Like there are people who specialize in machine vision. There's people who specialize in machine learning in finance and so on. So there's already specialization. I don't think that people, like, there's a huge gold rush. People coming into the field they just think that you can throw any data scientist at any kind of problem, but it's not really like that.
Is pivot tables in Excel, is that data science?
I guess so, yeah. Probably it is. But yeah, it's the simplest kind. So yeah, there's going to be better differentiation in sort of like the use cases and complications that arise in those use cases, and then also in the sort of phases of doing things. I think that there's going to be an even clearer separation between engineers and data scientists, whereas engineers focus on the infrastructure and supporting roles, and data scientists focus on the actual models.
Yeah. If we talk about the engineers, what do the engineers actually do at the moment inside these companies?
So what they do.
Our
fireplace died because I'm getting a phone call. I'll put it back up.
No worries.
There we go.
All right.
Yeah. So you were asking.
Good question. I was asking about the fireplace, but then I forgot what else I was asking about. I guess I was asking about one thing at least that's interesting to me is what do the engineers actually do inside these companies? The engineering part, is that really needed? Is that something that has that changed somehow in the last few years what they're doing? What is their role in regards to the data scientists or the ones that are actually building the models?
Yeah, I think that more and more companies are understanding how important the engineering part is.
Yeah.
Especially when you're doing like upping your scale or putting stuff into production.
Yeah.
What they do, they focus on like supporting the data scientists, taking as many tasks that are outside the actual field of data science, like stuff like setting up Dockers, setting up the cloud environments or on-premise hardware stuff, how to deploy code, how to get the results out of there, how to set up networking for like multi-node jobs and parallelization of training and all sorts of stuff that usually come from the DevOps field of doing things. And like data scientists usually come from university background, researchers. These people usually worked with something like a fixed data set that they train a model once on, and when they get that result, they just write a paper on top of that.
Yeah.
Well, obviously they trained many times, but once they get the result, that's it. And they don't usually have to collaborate. They don't do handovers. They don't recruit new people into the team. It's not an ongoing process that is continuously deployed, and the data is also changing all the time. So they usually don't have the background required to do all the engineering, so it makes it really slow if you don't have someone supporting there. And those are like huge areas of expertise, so why would you even expect someone to, like, we don't expect front developers to go on AWS and set up a cluster for serving stuff. So why would we do that here?
Yeah. Makes sense to have that support, and maybe tooling around that, such as Valohai, for instance, can help the data engineer's job as well to do it even faster. Yep. So let's jump to a few questions that we got from the audience before signing up. Ralph asked that what are the latest trends in machine learning for unsupervised learning and for transferred learning? Anything in particular that you've seen?
Interesting. Unsupervised learning, like outside of basic clustering stuff and so on that we've seen for quite a while now, there's not much happening. Like I think it's mostly theoretical.
Yeah.
I don't think I know any company that's really utilizing unsupervised learning. There's so many supervised tasks that are much easier to tackle today, and we already have the know-how to solve so many issues that we just don't have the enough brain power to solve those on the supervised side, and it's by far more researched. So I think very few people are currently looking into it.
In practice.
Yeah, in practice.
Like in a business use case.
Yeah, of course. There's like the research is really picking up, and there's so many interesting things that can happen, with unsupervised learning. But I think like the practical use cases are still quite far.
Yeah.
What comes to transfer learning, I think that's much closer. That's already used a lot. Of course, like just taking pre-existing models and then retraining the few last layers.
We already have a bunch of customers who are doing that.
Yeah, exactly. And stuff like that. But I think that if we look at the trends, one cool thing that I have seen pop up several times is like taking simulations and then doing transfer learning on top of that to get stuff done with much less data. So you train a model in a simulation, and then then on top of that you train it with the or do transfer learning with the actual data. That's really interesting. We'll see if we see more of that. I think we will.
Yeah, and that's a really nice. I want to take this opportunity to use the segue of simulations into the next question of what is the wildest thing you can imagine being done with machine learning? And the right answer is, of course, us living in a simulation. but anything besides that?
Why does it lead us to us living in a simulation?
There's a few leaps of thought in between.
Okay, what are the wildest things? I think we have to start from one of the subjects I like to speak is that like how limited machine learning actually is. It's like if you look at the mainstream media, it's much more limited than what people would like to let you understand. Like with the theory that we have behind, like for instance, deep neural networks and so on, it will never lead to a conscious being or what people like to call hard AI or general intelligence. It's still very much a thing of sci-fi. So I don't think like if we talk about the stuff that we have today, it's not going to lead into anything that's going to think on its own. But what will be the wildest things? Well, I think self-driving is going to be pretty wild. It's going to change the world completely. It's going to change one of the largest industries from, well, if I think transport is the largest industry in the world.
Yeah.
If we look
it's
at all of the
touching upon pretty much all other industries.
Yeah. So when we make the feat of transferring a thing from place to another scalable without human power, it's going to be so transformative that very few people understand how transformative it's going to be.
Yeah.
I think that everything that's implied by that, like the pricing, how low things can go, and so on, that's going to have a huge impact.
And that creates opportunities for new businesses as well. But
Exactly.
At the same time, I think I read somewhere that in Europe alone, 60% of the turnover of Europe comes from transportation in some way, either manufacturing things or transporting things.
It's going to
and in the US as well, a very big part.
It's going to be a problem. And I'm a little bit afraid of that actually, because like if you look at transportation alone, like the huge shift that we will see in the near future will require a lot from the lawmakers and like society to keep up. I would like to see much bigger efforts on the like the public sector side to how do we tackle this issue. There's going to be so many people who are going to be unemployed. A lot of these people might actually be unemployable. We might be able to like retrain some of the people. And one of the things that I think, because like people tend to talk about that, okay, transportation, like cars are renewed every 10 years or something like that, or even more in some countries. But it's not going to be like that, because nobody's going to own the car anymore. Nobody's going to need to buy a new car for this to happen. What we need is one large company like Uber or Lyft, and they will just own all of those cars. There will be no bank in the world that will not give them the loan to build every single car in the world, because they will own the whole industry. And it can happen extremely rapidly when the technology is ready. And it's not ready. It's moving every year. Like the estimates, if you talk with the experts, every year you talk, it's a few years further. But it's going to happen still, like in the somewhat near future, on a global scale.
And once it hits the inflection point, then it's going to speed up even faster.
Exactly.
Adaptation is going to drive up. And the lawmakers aren't usually the fastest ones to adapt to changes. So.
Exactly. So we should be really doing something about this stuff.
Yeah. So what should we be doing? Any suggestions to the lawmakers out there?
Yeah, I'm gonna. So it's a really hard one. I would love to have the answers for that stuff. I don't think anybody has the answers. I would embrace a very agile way of trying out new things, figuring out ways to change law in a much more agile way. without losing the support that the slowness sort of like it's good that democracy is slow because then it slows down the possibility of like takeover and stuff like that. So it's sort of built in the system, and that's a positive thing. But somehow we should be able to trial things much faster and test if things work. Stuff like basic income trials that we've done here in Finland. I think that's quite. It's been in the news a lot. It was really cool. I think we should be running multiple of those tests every year. I think there's no reason that we shouldn't be doing that. So basic income, I think, is one fundamental thing. I also think that we should go from like how we do taxation today needs to change completely. I think we're gonna need to start thinking about the whole sort of the concept of a country and capitalism from a fundamentally new kind of perspective where it's more towards generating happiness for overall for everybody instead of like this like old school capitalist kind of country.
I could go. I won't step into the rabbit hole of how to measure happiness and what is happiness and is that the ultimate goal. We'll take care of that after some sauna some night. But let's go back into a question and more practical questions. Let's see who asked this. Päivi asked about, do you see any technical or performance challenges when companies are building ML solutions?
Yes, I see a lot of technical and performance issues. I don't think I've ever seen a project that's just like, yeah, we trained a model and everything's good. So performance is always a huge issue, like to get models to work, and then your data is always changing, the world is always changing. So even the stalest model you might think is almost never actually, or I'm not, the not changing model. The model that you think would never need to change is going to need to change at some point. Like it's surprising, but that's just the way it is.
Do you think that's going to change more than, for instance, in software engineering, we also used to think previously that code it once and it's ready forever, and now we've learned that the software is never ready. Do you think we're going to make the same mistakes in machine learning predictive models as well, or?
No, I don't see many companies doing this mistake. I think it's like more of like the people who dip their toe in, but they really quickly understand that this is not the case. And in that turn, like I think that one of the big issues that people who delve a little bit deeper face is like getting iteration speed up. The same that we've already done on software development side. I guess like the past 20 years, if you look at it, like the thing that has been happening, like every single major advantage has been from making iteration speed faster. Like how can we deploy code instead of 4 times a year on a CD-ROM to 100 people deploying new code 10 times a day, and like how do we sort of drive safe faster, more nimbly? Like you have to have the seatbelt on, but the seatbelt can't limit your speed, kind of thing, and like finding out that, and the balance is going to be extremely difficult for machine learning. So performance, technical issues. There's, I think I brushed on it.
So one final question. We've had some questions here from the audience already that I asked, but one final question was about if you go back to Eero 2 years ago, what sort of has surprised you the most about machine learning? Is there something that's stuck out that you would have liked to know then that you could have changed something, or just as a general surprise?
I think the biggest surprise to me is still every day that how little is still actually done out there. It's very few early movers who have sort of taken the gauntlet and gone. And the other thing is that I don't think that people, especially on the business side, really understand what this is all about. From two perspectives. Number one, like actually understanding what the machine learning means, even on a basic level. Like I think that's something that people should definitely put the time and effort into. Like spend that 1 week every afternoon or every evening. Go through a simple course. It's not that complicated. Like it is complicated, but everybody can understand the basic principle. You don't have to understand code. You don't have to understand the math very deeply, but understand the basic principle of what machine learning means. But then secondly, especially when we're talking about deep learning, what we're talking about is making something scalable that wasn't scalable before. And when you're doing this big of a transformative thing, like let's say automation of diagnostics for a particular type of cancer, self-driving cars, self-navigating ferries, whatever it's always like automating some sort of job, task that was human powered before. And when you're dealing with something like this, you're dealing with huge potential upsides always. So if you're doing any kind of deep learning and machine learning, and especially deep learning, you should dream much bigger than most companies are doing. They should like really look at it and try and understand the use cases where they can really grab a global scalable market. And I don't think that many people really understand how big of a chance this is for them to utilize some proprietary data set. How much you should really invest. And the US is definitely better at this, but I still think that there's a lot of money out there that is very misplaced. And like the efforts that are put into stuff is like, we have this, we think we're gonna be able to diagnose this cancer, so we hired one data scientist and then no engineering support, and like you don't want to invest into computation like more than maybe $100 a week, and then these guys are running on laptops, and like they just don't look at the pay, like how much you're investing versus the potential upside. And because it's a scalable market, the early mover advantage is huge, because at that point when you have the working model, it's just a matter of sales execution. Well, obviously sales execution is not easy, but if you're enterprise, you probably have market access already, so it's more of a just like get that sales machine running and just take over the market.
That sounds good. That sounds good. That's sort of tied to our mission as well, to help democratize machine learning in a way that everybody can be those early movers, not only the technology unicorns.
Yeah, exactly. So one of the things I don't like is that the problem here is that as it's sort of encoded in the DNA of what machine learning and deep learning is, by the requirement of data, that only large companies have access to it. So at least trying to give the possibility to train, if you happen to have the data, to give the possibility to get that fast moving sort of model building environment for everybody who happens to have the data. It's still leaving out the people without the data, but it's a hard problem to democratize.
At least from an educational point of view, the people without that data can get to know what machine learning is, and maybe when they get out of school they can learn things and so forth. So there's always the next generation of data scientists coming from there as well. Hey, thank you, Eero, for this time.
Thank you.
If you guys have any questions or thoughts, you can email eero@valohai.com or fredu@valohai.com. Or if you just want one of these cool t-shirts, just send us an email and we'll send it to you in mail.
Also, now's the time to write it in the chat if you have one final question.
We will wait for 5 seconds. 10 maybe. If nothing else, hey, you can always write in the chat afterwards as well, or then you can just email the two of us and we'll be happy to help you as well. Alright, remember to subscribe.